Andy Chang is Senior Product Manager for Google when it comes to cloud security and risks. Well, actually, he's going to tell us more about it, and we are lucky because Andy, I understand you're coming straight from Mountain View for us this morning in Montpellier.
All right. Bonjour. Good morning. Thank you, Marjorie, for the introduction. I'm Andy Chang. I'm a product manager on Google's privacy and security team. And I'm very happy to be here with you to share a bit about some of the key learnings we've gained in security and in trust and privacy from running Google at global scale. So we've been very fortunate that 8 of our core products have reached over 1 billion users each. Now, the downside of that is that every minute of every day, we see the full range of bad actors and attack vectors across the web. And that means individuals, organizations, nation-states, attempting phishing, DDoS, cross-site scripting, social engineering, and motivated by financial gains, intellectual property theft, espionage, and just simple notoriety. There are several key principles that we take in our approach to security. The first of these is really defense in depth at scale by default. And the next is really trust through transparency, not just technology. In addition, abstraction and automation, as well as innovation at scale. What I mean by that for defense in depth is really innovating pervasive security through each layer of our stack. And for trust through transparency, designing in throughout our stack both the trust and the transparency to let our users, clients, and partners verify what we're doing. Abstraction and automation, which enables us to create secure abstractions so that our developers do not have to become security experts, but can still create and quickly deploy applications at global scale. And finally, innovation at scale and sharing those developments with the security community so that we all create a more secure web. Many of our users, our clients and partners, depend on, today still, a security model based on the network as the key barrier. They focus on keeping the bad guys outside. But in many cases, if the attackers are already inside the wire, or if they start inside the wire, the defenses and protections and obstacles are much smaller. At Google, instead of this hard shell, soft center approach, perimeter-based approach to security, we believe there is no perimeter. There's no simple abstraction or distinction between being outside and inside. For many of our services, their endpoints default to being open to the full public web. To support this, we have to design pervasive security at each layer and support the ability for them to be accessed worldwide. The way we think about security is really through 9 key layers of abstraction. First, from the hardware through the infrastructure, through boot, through the operating system, as well as the inter-process communications, through storage and the full data lifecycle management, through the network system, applications, deployment, operations, and the user. We firmly believe that developers should be able to focus on creating great and compelling applications, and that the core infrastructure should proactively protect them and secure the layers beneath them. This is how it runs at Google. And in our Google Cloud Platform, we enable this for our client and partner teams through services like BigQuery and App Engine. In addition, we think about the fact that trust and security have to be designed pervasively and integrated together to work together to support being at global scale and maintain a core Google principle that fast is always better than slow. Overall, from the top of the stack to the bottom of the stack, Google establishes and maintains identity, provenance, authorization, and authentication so that we can manage that the right code is accessing the right data, authenticated by the right user or service, on the right machine at the right time. And what that means in depth is that from the hardware layer, purpose-built infrastructure, including purpose-built servers, purpose-built storage, purpose-built network, and purpose-built full data centers. It means trusted boot, and it also means code signing from our BIOS to our bootloader through to our own hardened version of the KVM hypervisor. We have a curated OS, and then at the data and storage level, we encrypt everything at rest by default. And we encrypt in transit between resources we control. At the network layer, we are very fortunate that we have one of the largest global private networks. And that means that users, customers, and partners can connect with us locally in 80 different points of presence across 33 different countries, and therefore leverage our global private network to transport their data safely instead of over the public internet. At the application layer, we use binary verification to ensure the provenance of our binaries all the way back to their source. We also validate that the manifest of the build, and we validate that the correct code is being run on the correct machine, strongly authenticated at the time and place that it needs to be. Validating and verifying identity at time of use is a core Google principle. When applications are deployed, it's inevitable that some of the first users are in fact abusers. And so at the deployment, operations, and usage level, we use unphishable two-factor authentication for our users. We use TLS and certificate pinning to protect the transport. We leverage our global, unique view of bad actors and threats and combine that with binary reputation, URL reputation, login behavior, and application in-use behavior analysis to further protect the application. We also protect applications from DDoS through an integrated system in our front end. In addition to our investments in technology, we invested in 600+ software developers and security engineers focused exclusively on security and privacy at Google. And every day, they look to continuously increase and raise the bar on our ability to prevent, protect, defend, and respond for Google, for our users, our clients, and our partners, and the data they share with us. So one of the key things, again, as a first lesson, is defense in depth at scale by default. The second lesson is in trust through transparency. So in addition to the continuous investments we make in leading technology and expert people, we believe firmly that trust is gained through transparency. It's a core part of Google's security and privacy culture that we design in, where possible, the visibility so that our users, our clients, and our partners can see what we're doing, make choices, and verify for themselves. Examples of this are, for example, our transparency report, which we show the interaction and the impact of laws and policies on users and information flow. An additional example of this is in our Google Cloud Platform, where we provide audit logging across our Google Cloud Platform services. In addition, we've invested heavily in achieving and maintaining certifications, so you don't just have to trust us. You can verify for yourself. You can rely on the checks and verifications that trusted third parties have done. The third lesson for us is automate the best practices and prevent common mistakes at scale. An example of this for us is in cross-site scripting bugs. As I mentioned before, many of Google's services are available on the public internet. So cross-site scripting bugs are something we focus heavily on. Through a combination of frameworks, secure coding practices, templates, and also automated proprietary scanning, we've been able to reduce cross-site scripting bugs over 30% over 4 years. And in some of our products that hit over 1 billion users, they're effectively down to 0. The fourth lesson is really about sharing innovation to raise the bar and really investing, being active in, and supporting the broader security community. Examples of this are, for instance, our Vulnerability Rewards program, which we started in November 6 years ago, and to date has paid out over $5 million in bug bounties to security researchers worldwide. Another example of this is Beyond Corp, which is a paper we published 2 or 3 years ago sharing our vision about how we execute perimeterless defense at scale. In addition, Project Zero is an effort we've invested in that finds O-Day bugs in third-party software and drives their fix. In addition, on the open source community, we've invested strongly and shared out key tools we've created in forensics, in fuzzing, in cross-site scripting test beds to enable the larger community to leverage what we've innovated on. And then finally, as another example, in the KVM work we've done at hardening, we've shared these back to the open security community. We've also continued to fix and find the vulnerabilities in KVM. The kind of final lesson I'll share is really about addressing common cases programmatically and making it easy for users to adopt them. For many users, clients, and partners, while most of the spotlight today is on O-Days and very sophisticated attacks, the reality is users, clients, and partners still, in many cases, have very many security hygiene issues that are actually unaddressed. Course to some of this is patching and updates. Our belief is that patching and updates need to be automatic and programmatic. Examples of this in our fleet are Android and Chrome. As you see here, Chrome, with over 1 billion users, within each week of an update, the majority of those users are already updated to the patch system and therefore protected. And that's what we mean by updates and programmatic security at scale. In addition, while every year technology increases and improves and reduces the attack surface, the truth is that human beings, users, and employees still are a consistent weak point and a common source of incidents. At Google, all employees incorporate and use unphishable two-factor for access to any Google system or any data. In addition, for our Google Cloud Platform product, we strongly advise that the same unphishable two-factor is used in at least the admin accounts. So, kind of to recap, the 5 key things that we've learned securing Google at scale are that you need to do defense in depth at scale, and that allows our users, our clients, and our partners to focus on building what's next and what's great for their business. Trust is gained through transparency, and we enable you to see and control and verify for yourself and make choices about what you want to share and don't want to share with us. On automation abstraction enables security at scale, and then sharing and investing in the innovation and the security community raises the tide for all of us. You're safer, and we're safer as a result. And finally, address common issues and mistakes programmatically so that you can build a much more secure by default environment. So hopefully, some of these learnings have been helpful, and that from this you can draw some insights that can help yourself improve your own security posture. Historically, security has been looked at as a blocker and an inhibitor to innovation and velocity. But instead, at Google, we think that security, embedded pervasively through the infrastructure, is actually an accelerant to your business. Thank you very much.
Thank you so much, Andy. Trust and security as accelerators, enablers. Thank you so much again.